This recording will introduce you to the time value functions that are included in Excel. On Canvas, located in Module 1, there is a file as shown, Excel time value functions. This file presents the basics of time value using the functions in Excel. For example, the function MPV represents the present value of a series of cash flows, not the net present value. Nomenclature of MPV is not the best, but again, it represents present value. The way the function is set up is the first argument you put in is your discount rate. Then you block the variables that you want to use. And Excel makes the assumption that the first cash flow you highlight occurs at the end of the first year. So for example, in cell C5, we have NPV equals to cell B4, that's 13% the rate, and the block of cells B6 through B9. The MPV function in Excel is very helpful in that you don't have to type in the individual cash flows as you would using a financial calculator. The second function we want to discuss using Excel is internal rate of return, or IRR. The general format for the function is just to highlight the block of cells that you want to evaluate. The sum of the cash flows, or at least one of the cash flows, must be negative. IRR is premised on an investment, cash outflow, and then cash inflows. Again, the cash inflows can be different. In addition, the negative cash flow does not have to occur at time period 0, which is what IRR assumes here. The negative cash flow could occur in any year, but it wants money in and money out. So again, IRR assumes that the first cash flow occurs at time period 0, and the second cash flow the end of time period 1, etc. You cannot use blank cells. You have to put in a 0. So for example, if I delete the 0, notice the rate goes from 4.3% up to 5%, because what Excel does is collapse the column, and it assumes that these monies starting with this $5 are occurring sooner. So again, IRR provides the rate of return on investment. You need to have negative and positive cash flows. It assumes the first cash flow period is time period 0. Other functions in Excel for time value are equals future value, number of periods, payment, present value, and rate. All of these functions are for annuities or lump sums. That is, the cash flows over the life of the investment are the same, or just having a present value and future value. The default for the functions is a type 0. That is, we have a regular annuity where payments occur at the end of a period. Type 1 is for an annuity due when payments occur at the beginning of a period. An example of that would be paying rent, where rent payments usually occur at the beginning of a time period. Again, the function assumes inflows and outflows, so you have to be careful about the signs of your inputs. An example of this function could be rate. So here we have rate. We have 3 time periods where the payment for each time period is $11 and the initial outlay is $25. Notice it's a negative 25 because it's cash coming out. So the resulting rate of return is approximately 15%. As all these functions, you have, again, number of periods, payment, present value, that's what we just had. You can also have future value, which is optional. The type, again, 0 or 1 for a regular annuity or annuity due, and occasionally, which we should not have to use if the cash flows are very volatile. Sometimes you have to make a guess for Excel to calculate the true rate, but we shouldn't be running into that. What Excel does not have is a function for the future value of a series of unequal payments. So to calculate such a future value, you just need to build a simple series of formulas in Excel. So let's assume we have a 4-period regular annuity. That is, the payments occur at the end of each year. There's 4 unequal payments. And we want to know what our future value is going to be. So the first payment of 40 C35 gets compounded at the interest rate of 12%, so it's 35 times 1.12, and to calculate the future value, we're going to compound it for 3 time periods. B38, that's 4, less B35, that's 1. So we're calculating the future value of a lump sum for 3 time periods. The $90 gets compounded at 12% for 2 time periods. B38 less B36, 4 less 2, for a future value of $112.90. The $60 is compounded for 1 time period, and the $40 that occurs the end of year 4, there's no compounding since the cash flow occurs at the end of the year. The future value is the sum of the cash flows, so the future value is $276.29. A very useful addition to time value functionality in Excel is using the XIRR and the XNPV. This can be used when payments are not equally spaced, and you actually enter a schedule of payment dates. So in this hypothetical, let's assume you make an investment of $25,000 on June 30th. September 1st, you expect to receive a distribution of $10,000. June 15th, 2015, over a year away, you expect, roughly just under a year away, you expect to get a distribution of $8,000, and then April 10th, you expect to get a distribution of $13,000. The XIRR function is you highlight first the dates, then you highlight the dollars, and it returns the expected rate of return. If we used the straight IRR, assuming the cash flows were equally spaced, then our return would be 11.81%. So the XIRR is very powerful. As a review of time value, the second tab amortizes a loan, where amortization means, as you know, taking the loan payment of $1,582 in this example and breaking it up into interest and principal reduction. So in this example, we're borrowing $200,000 for 15 years, or with monthly payments, so it's 180 months. We're borrowing money at 5%, or at a monthly rate of 0.417%. First, using Excel, we solve for the payment. Using the payment function from the previous tab, B3 is a rate, the monthly rate. B2, the number of time periods, and minus B1, the loan amount. The resulting payment is $1,582, and that's just copied down. With a loan balance of $200,000, the interest for the first month is $200,000 times the 0.417%. The difference between the payment and the interest is the principal reduction. Then the principal at the second year is $200,000 less the principal reduction of $748, gives us a principal balance of $199,252. Following that process for all 180 months, the loan is fully amortized at the end of 15 years with a balance in the 180th month, $1,575, the interest of $7, principal reduction $1,575, and a loan is fully amortized. Finally, we want to discuss, review effective annual interest rates. So I set up a little example in this third tab. So let's assume that you put money in a bank or an investment where you're earning 0.75% a month. What is your annual equivalent rate? If you just multiply 0.75% times 12, you might say the annual equivalent rate is 9%. That would be wrong, because this does not take into account that there's monthly compounding, that every month you're earning interest. So earning 0.75% a month, earning interest every month, is the equivalent of getting interest once a year of 9.38%. And that's the annual equivalent rate. 1.0075, 0.75%, raised to the 12th, less 1, is your 9.38%. An example of this concept is shown below. Let's assume that you borrow $10,000 for 4 years at a simple interest rate of 10%. So your interest is $1,000 a year. So your total due on the loan is $14,000. The $10,000 you borrowed plus interest for 4 years, $4,000 is $14,000. You're going to make quarterly payments. So you're going to make 4 years, 16 quarters. Your quarterly payment is $875. Well, the question, what is the annual rate you are borrowing at? This is a good example of why we have truth in lending. So first, we solve for the quarterly rate using our Excel time value function. Rate, 16 time periods. The payment is $875. The present value is a minus 10,000. So the quarterly rate is 4.264%. Converting this into an annual rate, take 1 plus 4.264%, because it's quarterly, raise it to the fourth, less 1 to turn it into a rate. And as shown, the annual percentage rate you're borrowing at is 18.18%, not 4 times 4.264 or 17%, and certainly not the simple rate of 10%. This is again why we have truth in lending. For many years, consumers were sold loans being told they were being charged 10% per annum when they're really being charged 18% per annum. And just to prove that out, here's the quarterly interest of 4.264% with the loan balance of $10,000, the payment, a review of the amortization, and again, after 16 months, the loan is fully amortized. If you need a review of time value concepts, I posted in the module called Review Materials the time value chapter used in the prerequisite course, and that'll serve as a good review for you. In addition, chapter 2 of the textbook has a review of time value concepts as all. The homework that is due next week also has some time value problems for you to solve. This concludes the recording that reviews time value concepts using Excel time value functions.